Welcome to this podcast. I have with me Nitish Shrivastava and Pradeep Sharma, technical leaders from Persistent AI team. And I will be discussing with them various things about SASVA 4.0 launch and beyond. And this is an interesting time. We are sitting last day of the month and the quarter and the year, and lots happening in the AI field. So how you guys are feeling?
Well, you have chosen the wrong day here because it's the financial year end. We have our quarter close today, but then 4.0 release is coming out in a couple of days. I think for us it is an exciting time, tricky time, but then extremely excited about what is coming out in 4.0.
Glad to hear that. I'll start with this 4.0 release. And this is almost the third year of SASVA journey, Nitish, and fourth big release. So when you look back, how do you see all these releases? How important 4.0 in terms of a milestone and a turning point in the SASVA journey?
Yeah, I mean, third year, ever since we released our 1.0. 1.0 was a crucial release. It was ahead of time. When you have a precedence and you are following something which is out in the field, your life is easier because a lot of validation comes through the field. When we started 1.0, there was no precedence. We were not sure how users are going to interact with the system. We were not sure about how AI different modes are going to collaborate. We were ahead of time. We talked about the overall SDLC as like a prime focus area. We were staying away from developer productivity. We got into 2.0. 2.0 was more about bringing all these collaborative workforce together, but the rationale was still about how a not so competent model is going to treat complex use cases, and hence orchestration was extremely crucial back then. But 2.0 was focusing more on getting AI deliver quality results for complex problems like migration, modernization. We got into 3.0. We realized that by then cursor was a talking point. Vibe coding was already in the field. People started relating how easy it is for AI systems to sort of provide those interfaces to users. 3.0 was bringing consumer flavor to our overall narrative while we stayed core to our philosophy, but then 3.0 was bring it more consumerized. And then you asked a very interesting question. If you see industry and the type of productivity they have seen, there is a reason why it is underwhelming. A developer alone is not going to give you the desired productivity. And hence, we brought our core theme back in 4.0. 4.0 is beyond developer world. 4.0 is more about bringing collaborative workspace. 4.0 is more about staying private, staying secure, staying core to complex problems, but in a way that is natural to engineering world, where my resources are distributed, my teams are distributed, and I have a system that is bringing all of them together. So to me, this is completing the whole cycle because we started our journey there. Over the period of time, as models have become more mature, a lot is done with model, but we always believed that it is the power of collaborative workspace, it is the power of bringing multiple resources together and having a smart orchestration around it is a way to go. And 4.0 is taking that leap. Today, again, for us, it is a defining moment. At the start of our discussion today, I want to set our stage that we are looking at something which is not having any precedence. No one has any system that has come out in similar mode. People have tried this science in different domains, but for an AI system to have something more collaborative, we are the first one to talk about it. So the moment you talk about something which is new, it is difficult because you have to envision how users are going to accept what is the reaction, whether it fits into their everyday work. And hence 4.0 is a defining moment for us. We believe this is going to set a new trend. We believe that this is going to define a new way of working in this world.
And we will unfold this story of 4.0 in our discussion today as well. But couple of things stood out for me. One is that this field is changing very, very fast. and a lot of things are happening in different areas, whether it is models or the way people are using and the focus areas. And one thing is very clear, that it is important for people to have a vision and a focus, and to decide that in which area they want to win. Otherwise, it's very easy to get lost in the entire spectrum of changes. I would like to take you back a couple of years, right? And people were talking that time about a lot of predictions, like autonomous agents will check production code by 2025, right? AI will replace half of all developers, or foundation models will solve enterprise modernization. Now, when now we have the data to check out some of these predictions, what is your take? What was right, and what was some of those fantasy we thought about as an industry?
Yeah, I mean, I'll start and then I'll have let Pradeep also join in, because this is one thing we talk every day. You know, we had a philosophy. You know, I don't know if you remember this particular document, right? We wrote it almost 2.5 years ago. Right?
Yeah.
We talked about how you need a deterministic brain with generative science. So we stood with some of our philosophy. We have seen that industry change their way. You know, you are right in saying that foundation models have become smarter. Just go back in time and see a GPT-2, you know, the early days of how OpenAI models were behaving. People started focusing on purpose-built coding models. So new models have started coming in. We had a belief that the more we go forward, it won't be one single large model. There will be many purpose-built models that will stay back. I think that sort of continued. If you look at now the reasoning models slowly, if you look at their benchmark, they are doing very good in certain area, and then they say that, well, it is very good for coding, it is very good for general purpose stuff. The model companies have focused just on making that one large superior model that can solve all types of problem. We wanted to focus on a layer around the models. We believed that the orchestration layer is going to be the defining thing for any AI system, and having a deterministic thing will give you accuracy that you need for all of these critical systems. So for us, they stayed back as we were going from our 1.0, 2.0, 3.0. All of it stayed relevant in industry. Today, we see everything that you see in, you know, and I'll take some examples. You look at Anthropic, how Anthropic models are exposing, Anthropic tools are exposing skill, for example, right? They were the things that we came up a couple of years ago, that you need things like that. Now, where we went, not fantasy, but I think we underestimated the complexity around hardware. We underestimated how not very small, but a medium size model can fit into an organization paradigm when the cost is in check, but your speed and performance is at par with what you get with foundational model. I think these are things we learned. We realized that you can't have small infrastructure supporting and giving the desired result. So that was our learning. That led foundation to some of the things we are doing in 4.0, which is about cognition lab. We will talk a little more about it as we go along. But for us, yes, the core theme stayed back. There were some changes. We looked how market is progressing in these areas. We accepted, we adopted many techniques. And today, as we are going from 3.0 to 4.0, a lot of that learning you would see in our 4.0.
So basically, the whole industry invested last 2 years billions of dollars around trying to drive this single developer productivity, but not that much of value was derived at the enterprise level. So the question is, what went wrong, and where all this money actually went in last 2 years?
I mean, it's, providing you the, when you ask a question and you get a quality result today with a model, you got to have a very, very large infrastructure backing it up. Most of the companies spent money building that infrastructure. As you look at OpenAI, you look at Anthropic, and how Microsoft, AWS, and then downstream coming to CoreWeave, Together AI, Vulture, DigitalOcean, uh, there was big investment on elevating the infrastructure stack. Orchestration stack, I would call out, there were investments coming out. You look at Cursor, you look at how Windsurf, now it is Devin. You look at how LangChain and open source community, there were investments there, but predominantly the focus was on improving model accuracy, that a large model will be able to do a lot of things on its own. And I think again we will talk in depth about how alone focusing on developer productivity and having a very very large good quality model is insufficient in getting you a desired result. I think industry stayed focused there, which was required. I think the focus is gradually shifting towards having an agent which can be trustworthy, and then having an ecosystem where you bring multiple agents to participate and deliver you the desired result. And industry is slowly progressing in that. I think the focus is still on that one large good quality model. You see announcements almost every other day, and there are new innovations happening, models are improving on its own. So that journey will continue, and I think there will be investments in that area. But significant investment have started pouring into agentic world, and I think there are some defining moment. We talked about OpenClaw as one of the most critical moment in this AI history, because it showed the world how a simple orchestration and having a combination of multiple models can give you something which you can use almost daily. Slowly Nvidia picked it up, so you will see investment coming in agents, you will see investments coming towards orchestration. But at this point I think we are at a cusp where large models are becoming super powerful, and industry somehow they are still of an opinion that, well, we should continue investment there because at some stage these models will give you the result. We see the other world as well, that while these big models are good, but you need to invest significantly more in order for your orchestration system to give you the results.
Okay, so let's shift gear. And Pradeep, while the market was busy promising that AI can do everything, you and your team was spending a lot of time last year building something more grounded. So it will be good to know from you that at the high level, what are the headlines for the capabilities in 4.0, and also touch upon that why the CTOs who have been burned with this AI hype, they should believe in this story.
Sure. So basically, you see, we are talking about two different paradigms here. One, that everybody is talking about, there is an autonomous system. There is a very big model, like Nitish mentioned, and it will just do everything. You give it a very big model with big context, give it lots of hours, there is no token budget, etc., and then it will come up with good results. That is one way of thinking. The other way of thinking is that there was a team with different personas, different developers. They are using AI in their own capacity. They are using best of the models and best of the tools and increasing their own productivity. But what we have seen is missing is, and which is required for the real world, is something in between at a higher level where there is a collaboration, something, the designing happens at a higher level. And we move more and more from runtime AI to more and more design time AI. So we may use AI, experts may use, they may define workflows, they may define those deterministic tools and then ship it out to individual teams, and then they work further. And then they will further use those AI systems to create those validation scripts and move more and more from runtime AI to design time AI. I think that is required for the success for the complex world, which is the enterprise world.
Got it. So let's start with the Canvas 4.0 and the assessment. Last time when we spent time on this topic, we talked about that assessment has a fundamental gap which nobody is filling. Normally, when people think about assessment, they think about it as like a scanner, run a scanner and get a report. But what I understand from you is that you treat it very differently. You treat it as a building block for the organizational memory, and a system which can actually help you in taking the discussion forward when it comes to the AI journey. So walk us through what is Canvas 4.0 and why it is a generational leap from the conventional way of looking into assessment.
Yeah, I mean, go back in time and look at some of the traditional, let's say, security as a space. There were tools, they would do vulnerability assessment, and there are some tools that can do it better. So there is a journey there, that when you talk about can you discover everything in my ecosystem, your discovery will have to have a better capability to get the desired result. You talked about organization knowledge. For us, assessment is native to everything we do. You connect your systems, the systems are bringing all that knowledge together. There is this whole context management that happens. That is the core of everything that you are then going to use for. For us, assessment is that journey. We realize that there are two extremely critical aspects to any assessment engine that you do. How do you get people, process, technology, data from all systems and do a deep level analysis of how your team is collaborating, what is your hygiene, what types of tools, technologies we are using, what types of third party open sources are being used in your ecosystem. What are the best ways to detect all that? Most of the companies are struggling with doing a measurement of productivity today. So for us, that was another problem area, that can I create a system which can connect to various sources and give me a real view where I'm not relying on users making mistakes in feeding data. The other aspect that we thought about is many a time these assessments are done under a firewall. You should have a system that can be brought into an ecosystem and it is not sending data outside. So how do you build something which is portable, which can come to an organization? Can I ask an organization to buy multiple GPUs, where they are spending many hundred thousands of dollars just to create an infrastructure? There is no way we can do that. So for us, 4.0 assessment is about going into that journey where we are bringing a compatible model. We are bringing something which is easy to bring into an organization, something which connects various systems. You have a very deterministic workflow around it. You capture data, you take out noise, and then you produce metrics that can be used for any agentic system on top of it. If I'm doing coding, there's a lot of information that I need from my repository. Assessment builds that. If I'm creating a project plan for a team, I want to know your team's hygiene. Assessment does that, right? If I'm doing a technology upgrade, migration, I need relationships. I need to understand how systems are talking to each other. Assessment produces all that. If I want a developer to write a code, I need to have an understanding of the complete system, which is not one repository. Assessment produces all that. For us, 4.0 assessment is about building this connected ecosystem, having agentic system which takes away noise, something that gives you a result that you can trust on. And that is the basis for everything else that we do in 4.0. Now, who uses it? It is, if you see the landscape, a private equity trying to acquire a company, they want to know what is good and bad. A company looking at its own portfolio wants to do some analysis about how they can evolve from a traditional SaaS company to an AI native company. Someone who is trying to offshore a team, someone who is looking at a technology upgrade for their stack, someone is trying to split certain products. Companies looking at various different objectives are able to use assessment to get their objectives done. And that is the power of our 4.0. The agents that are backing, the agents that are building, they are designed to work with with small models. The agents are orchestrated in a way that you can define, and Pradeep will give you a deep understanding of how we have designed the brain which is powering our 4.0. Our assessment is not about running 5 tools, getting a report and consolidating with AI. Even the tools, the way we capture data, the way we correct data, these are things that keeps it ahead of most of the common things. And for us, this is native for every work we do in software engineering, right from planning, coding, testing, deployment, and likes.
And like we always say, right, everything starts with assessment. And if you are working on a complex software, which is like 10, 15-year-old, we have seen that, it has its own journey. Different developers work on it. They use different tech stack. Over a period of time, different decisions are made. So all that knowledge is really required to take the right decision further when we take over that project or product and do any work on top of that.
Interesting. So Nitish, you talked about planning. So can you double click on the entire planning and effort estimation? Because today the way industry does estimation, and these are like big $1 billion modernization projects, is like in 2-hour meeting you come together and do some gut check and sticky notes. So how this entire assessment Canvas 4.0 will change the way we look into estimation part?
Yeah, I mean, you look at, so I had an interesting meeting with a business leader, and he talked about running a almost 6 billion portfolio. And during the discussion, he talked about how they are doing a lot of fixed cost project. They come in a meeting, they look at requirement, get a few architects, they design a solution and say, I'll take 1 month to deliver. And for them, a 30% leakage is a norm. So they bake in 30% leakage, that my assessment will go wrong 30%, and they sign a contract. They talked about how in that economy, even if having a lever of 20% accuracy, more accuracy, can help them save, almost $1 billion in their portfolio. And it is a problem everywhere. One of the thing, Pradeep and I, we were talking for many, many hours about how modern system planning will happen. In past, you would get your teams, you will get people, all the architects and your business leaders, what team is going to support you, and you will do some sort of planning, and you say that I'm going to take 1 month to deliver this feature. I will have these many resources going to work on it. Now you have AI agents coming in. How are you going to now redefine your estimation with AI agents? How do you estimate what is the throughput for an AI agents, right? So there is that problem of identifying what type of new resources are brought in. The automation, the model is going to give you some gain, right? And on top of everything, you want to be absolutely certain about how each task are going to be taken up by these agents and human combination. So for us, when we do assessment, it sets stage for identifying each items for any work. Let's take modernization as an example. Modernization doesn't have one right or wrong way of doing things. A modernization can be creating one microservices, it could be just rewriting everything from scratch. Which is the best possible mode that you can go in? How do you design that? How many people are going to work? How much of AI contribution will be there? If you master that technique, everything else will follow from there. And for us, when we talked about brain unlocked that capability. So today, when I'm doing an assessment, when Pradeep explains you about brain, it is basically going and creating your blueprint to sort of understand what is going to be your to-be state, even before you actually create a to-be state. And then you define what type of task, how many resources, what efforts are needed, and that is fed into a system to create any estimation. Now, where is it used again? You look at it when companies are looking at a volume of work. Today, when they have accurate assessment, they can take decisions whether investing X dollars are going to give them a desired outcome from a business acceleration perspective. The decision makings become simpler. Similarly, people are using it to sort of estimate that I'll take X number of days to do a cloud migration from one cloud to another, and hence the forecast becomes better. It is a win-win-win for all the parties, because a hyperscaler can get this customer faster on their cloud, so there is a realization of their dollars faster. For the company, they will be able to move faster without having to burn money twice, and for companies who are providing them that service, they get that additional service. So we believe that estimation is probably one of the most complex tasks in industry, and hence we thought that our assessment and estimation will be the backbone for all of the planning activities we do. So in Canvas for 4.0, you would see these out of the box agents that are there, which are designed in a way that these complex problems it can estimate, and it can give you very near to like a real timeline of what would it take, what type of changes will happen, and not just for a developer or one product, but everything around that. A complete ecosystem plays there. Very, very important feature, and again, a big problem in industry today, where no matter which AI platform you use, it will give you an estimation. You run it twice, it will give you a different estimation altogether. So you have to master that, and for us, this was one of the core problem that we have taken up. And 4.0, when you use that, you will realize that it is definitely solving one of the most complex thing out there. I remember Steve Jobs' interview, when he talked about how Pixar was approaching motion picture, right? And when Pradeep was presenting it, it resonated so very well that when you look at the old movies, when people were creating animations, or even before that, at some stage when you watch a movie, Steve Jobs' point was that when you look at it, you said that, well, this looks crappy. Didn't they realize it when they were shooting? No, because they could only get back to an editing room, and it was that time when they realized that something went wrong. But by then the actors were gone. You've invested so much of money, and you can only invest a little more actually. So then you start losing grip on a movie. When Pradeep was explaining the concept of brain, and this is not today, by the way, once again, this is a almost 3-year-old write-up. And when we presented brain concept for the very first time, we realized that just like movies, when you are building a product and you use AI systems, build a whole product, at that stage you realize that something has gone wrong in foundation, something has gone wrong in selecting a particular technique, your algorithms were messed up. And then you have only two choices. You can go back and recreate everything, or you could just live with it. If you live with it, you are going to have more tech debt coming in, right? Because you are now creating bad code. People are not going to enjoy it. But then if you go back, what Pradeep talked about, you're going to spend as much money or even more now to correct things. Plus, you can't rely on one guy to take that decision. You understand? I think what he talked about collaboration right now is you need various roles to sort of come together and solve a problem. And this is what brain is unique about. Brain is like you create a movie before you made a movie. You could see everything, how they are all going to come together. You have the representation of everything ahead of you. You know how each subsystems or sub-agents are going to collaborate. You have ability to go back and forth. You could change certain settings. And at some stage when you are comfortable with your movie, you can share that script with the rest of the guys. So we are bringing architecture-first strategy back again to the center stage. Our strategy is about bringing core architecture at the center. We have real architects collaborating. When you are sure about your storyline, you get different engineers to collaborate. And at every stage, you're not waiting for the final editing room. You will have editing at every stage, and then you build a product. And this is the fundamental difference what we bring to the table as compared to even our older strategy. We talked about a deterministic brain, but for us to get to a stage where a large complex problem is approached with this simplest strategy and a brain which is shareable, becoming a foundation for our agentic system. And this is the core for everything we are doing in 4.0, all different things that we are building around it. And we believe this brain, the overlaying foundation is going to define all types of agent as we come together.
This is very interesting. Now let's go deeper into SASVA 4.0 and this agentic approach, Pradeep. Now tell us, what are the important capabilities which you have added in 4.0?
So if I explain further what I just mentioned, if you have a problem that you are trying to solve, a complex problem, and on one hand you have a problem, on the other hand you have a set of personas, resources, systems, and models. And together, using these, you are trying to achieve what you are trying to achieve in a deterministic manner. So that every time when you are trying to do that, you should achieve almost similar results. That's what we expect in any enterprise software, right? So what we provide in 4.0 is there is a team of architects. So it is a little bit similar to the plan mode that you may understand that every IDE tool, they provide a plan mode. That's just the starting, that you create a plan and then the same developer, or maybe you can give a plan to someone else and that is being executed by some other developer. Our approach is fundamentally different from this, taking it many level higher and much more distributed manner. So the architect and the team of architects, they will sit together and they will create the overall layout and workflow of the problem that they are trying to solve. Everything will be decomposed further into various tasks and subtasks. We will define that for each task and subtask, which resources should be handling it, which agent should handle it, which persona should handle it, and we will be assigning it to them. And after that, we will push the execution. And once you do that, individuals will get triggers. They will get to know that yes, they have to work on their part. And like I mentioned earlier, when they do their part, they still have freedom to go back and forth. And once they finish, then the overall ecosystem, the other waiting entities will get to know that yes, now they can proceed further. If it's an agent, it will automatically proceed further. If it was the entity waiting is another developer, another human persona, they will get a trigger via various means. We support various communication channels. And this is the way, step by step, everybody will do their own part. And slowly we will move in the desired direction. And at every step, which we always mention, right, that if whatever you are doing, if you can't validate it, if you can't measure it, you can't validate it, and you can't better it. So it is very important for us that use AI as a generative tool and move more and more things to deterministic side. While creating those deterministic toolkits, you may use AI again, but then these are the architects. They are using their own wisdom of decades of knowledge, and they are challenging AI at every stage, and then creating those deterministic toolkits. And that is there in our workflow at every stage that glues things together. And once it is given to these tech leads, they can also, it's not that they will just take their workflow and execute it. So yes, they can. There are agents that we have defined, the architect has defined, and then it can be executed but it is being executed by that component lead under his eyes. He is reviewing it, he is challenging the AI whether it is correct or not. And again, like I said, even he is supposed to create those deterministic toolkits further, so that more and more we move away from the generative science to deterministic science.
And I'm sure you'll say that this is a very complex system, right? Yeah, but then, so the good thing about most of people in our age group is we have seen many waves, right? And, you see the typical fashion wave, right? They come back again. When we see some new trend now, we say that, oh, wait, this is 80s trend, this is 90s trend, right? When someone looks at this type of system, they will have the similar reaction that, well, this is a simple event management, making a collaborative thing. We have seen it during low code, no code era. Right. We have seen it in many enterprise applications when distributed systems were becoming common. So So well, this is not a new thing, and no, we are not saying that this is a new thing. It is just solid architecture using AI to advantage, and hence it is able to deliver better result. It is the simple thing which is done in a way that you can't just have one AI system. I heard a philosophy recently, and a little deviation from your original question. Someone talked to me and he presented a view that in modern times agents will work all night, humans will read and review all day. Yeah, they can do that. Agents hallucinates. Now the whole night it is hallucinating, it is taking you far off, and now you guy, a poor guy coming and taking that particular system back into a motion again. You want AI to be in a lane, right? One of the things that Pradeep always used is that philosophy of a horse with all the guarded thing, because you want this horse to sort of go in a particular direction. The directions are designed by architects, and the most interesting aspect into all of it is, again, architect is at center, your context is at center. You are designing a swim lane for your AI systems in a way that your AI system can't go out of it. And then these are not a lengthy process where agents are working for 5 hours to do a job. These are small milestones where you have ability to do corrective measure at every milestone. And I think again this is a solid enterprise architecture that was there all across waves. We have seen enterprises adopting to it. We are bringing it at center stage back in AI world now, and that is why we are bullish about it. We believe this is a way systems will be designed. We believe this is a way you are able to solve complex problems. You just can't have one agent or a developer alone take many decisions. Creating a small app with vibe coding is good, but try to do a large complex migration, and you will realize, like in medicine term we say that 80% efficacy is as good as 0%, right? Migration is like that. You have done 80%. What am I going to do with 80%? I need 100% migration, right? I want my system.
It turns out that that 20% will take maybe 90% of the time.
Oh yeah.
We have seen it time and again.
And this is why people say that I've invested. I know one guy who said that I invested more than 50 million at enterprise level, bought almost every tool, and he was not opening up. When you dig more, he realizes that his productivity is less than 5%. And I always say that if you have a good taskmaster, that guy alone with a little bit of micromanagement can get you more than 5%. So what are we doing? I think slowly we all realize that having proper guardrail, having a model which is doing good job, but then you are guarding everywhere, is a way you can start believing, trusting in a system, and that is the way agents are going to be designed.
Yeah. And another point to note here is that just like any distributed system, brain is a distributed system, right? So to get things right, we have to solve the same problems of fault tolerance, scalability, high availability that is desired for any distributed system.
Yeah. So a lot of important points both of you have shared. So one thing, Nitish, you talked about that 80% is not good enough, which is true. Like in an enterprise case, until unless the system is working well and up to the expectations, it is not good, right? You cannot launch a 80% ready system. Also in our customer discussions, we have noticed that a lot of senior leaders talk about that while they are gaining the productivity at the individual level up to like 25-30% in some cases, but when we ask the question that have you cut down your bill by 30%, the answer is no, because it is not translating into the enterprise productivity. But I want to connect back with the SASVA capabilities. You talked about two important things. One is the distributed system, which is kind of replicating the conventional way of thinking about software development, where people are coming together in real way, and then they are helping to get the high level design right, so that when AI is taking that journey forward, there are no surprises towards the end. So this looks like a very important feature in the platform. And the second thing you talked about, the brains part, where if I am very good in a particular area, I can create a solution, and that approach can be leveraged by someone else who may not be as good as the expert, right? So can you just summarize these two areas for our viewers, because these are two important capabilities.
Yeah, so see, if you see that before AI, if we had a team of, let's say, 50-member team with few architects, multiple sub-teams, etc., what we believe is that maybe you may go from 50-member team to a 10-member team with few smart people, but still, there are people who are expert in different areas. We don't think that there should be one person who will suddenly become, just because of AI, now suddenly you may feel, because AI will give you that feel that suddenly you can ask something and suddenly you have a wealth of knowledge, and it gives you a false pretense that yes, now I know everything, but that doesn't work that way. And if you can't validate, if you can't rein in the AI in the right direction, then like Nitish mentioned, you are making a building without any proper base, and you will be burning money and wasting lots of time later on. So our philosophy is that we don't think that autonomous systems will take away a complex job. They can do anytime soon. But we do think that if there's a large team, it now becomes a smaller team of smart people, and they work together. And like I mentioned, that at a higher level, the brain is designed with all these resources. Not only so when I say resources, again, it could be agents and machines and models. Everything is known, and personas. And now and lots of deterministic toolkits have been created in advance. I think we strongly believe that is the way to go to solve a complex problem.
Let's take an example. Let's take a typical enterprise problem. To people who are looking at this video, let's understand that when you are building a product is sitting in a large ecosystem. So I'll take an example. I'm designing a gateway. I have a code. My code is building. I need to produce a gateway. I'm using a Mac machine, which is my personal laptop. When it is building a gateway, it needs to get lots of different modules to sort of come together. I have a build system, I have a build server somewhere, right? Then I bring the code that I have produced. It is built, it is bundled in a distributable binary. I have to take it to a remote machine. I have a whole test environment built there. I test it there, and then I get a report which validates whether my code is good or bad. So if you look at a typical development cycle, you have a developer, he creates a new branch, he forks from his original branch, he will make his submission there, he will get a local build, he will do his sanity check, the build is put into a test bed, a testing team picks it up, performs a testing which is generally distributed in this example. I get all feedback comes back to the developer. Developers will make corrective measure. It will go through that loop again. And that's how typically software is built. In our current technique, we are saying that why don't you take a developer productivity platform? A developer is writing a code. AI helps him generate a code. But it is not going to cover all of these hops for him, right? So how do you get real acceleration here? Because unless your feedback system is integrated, and feedback system is not one machine, it is distributed, it is going into multiple nodes, you bring every resources together, you are going to compare your test results with your original system, and then you take a decision whether my code is good or bad. If I am able to connect all of it together, I am able to get the desired acceleration, and that is where productivity improvement happens. So what Pradeep is talking about is a system that does everything. It's not just I write a code, but what about getting a feedback and recreating a code?
Yeah, and we have seen, right, that if AI is very good, if you couple it with feedback system, like if it is creating a code and if it has access to a compiler, it can course correct. So a very important point what Nitish mentioned, right, that if in a distributed system, even though some part, the building is happening in a different machine, and if you can bring that response back to the machine which generated the code, you will get the magic of AI.
So my next question is a little more about the business side, Nitish. So one of the things is that today in the market, similar platforms or similar capabilities can exist at $1 $19 or $20 per user per month kind of thing, Copilots and ChatGPT solutions are existing. So my question is that why you don't offer this in a public domain and then everybody can just pick it up and then start using it?
Yeah, I don't have billions of dollars to sort of burn on building a community alone. But on a serious note, if you are doing a developer productivity solution, if you are building something for an engineer, the law of average will justify your $19 or $10 of your spend. I have seen model companies now giving their code platform for free as well because they make money there, right? But I think when you are looking at a complex ecosystem, we talked about a system where a developer is using a build machine, there is a deployment that is happening, you are getting that feedback again, you are reviewing your logs, you are running some of the test scripts on that. You are going to use a lot of tokens, right? You are going to use infinite resources in order to get something right. And if you are solving complex problems like migration, this is done at a much larger scale. I don't think it would be fair for anyone to compare that work with a developer productivity and say that, well, if I can use a $19 system here, why can't I use a similar system here? I don't think people are expecting that way because these are complex problems. You look at the landscape and the type of things people were doing in past, they would spend many hundreds and thousands of dollars to get a migration done, right? So for us, the consumer community is lucrative because with our small model approach, with our approach of using deterministic systems, we can be profitable and we can have a larger user community. But the solutions we are building is not about developers, it is about the overall ecosystem. So it is an enterprise-like solution. So we decided to stay away from $20 subscription for now. Our platform is open for people to sort of try it out. As we are talking, there are many users who are using it. But when you are solving complex problem, it is an enterprise problem. Our solution is for enterprises for now, and we want to stay there for at least some foreseeable future. At some stage, we will open it up for consumers to sort of use their credit card and they start using this product, because at some stage with modern systems, the way they are built, there will be similar requirements even for an engineer who is working on it. Like if I'm developing a code, OpenClaw is an example, and I want to share my experience. We will have a demonstration. You will experience a little bit of that later. If I am trying to make a native workflow around an OpenClaw, I still need a distributed system. I still need to make code changes, deploy on a machine, test behavior, get feedback, come back, make changes and do it over and again. So even for engineers, at some stage, the requirements would open and it will go to that direction. But for now, we chose that we will be an enterprise specific solutions. Our customers are using our canvas for estimation, for assessment. Our engineers are using it to build complex problems, to solve complex problems, to build large scale enterprise applications, migrations. A lot of migration type programs are there which are distributed in nature. So that was a business decision we have taken. The platform is, by the way, open for individuals, but we are not really coming out aggressively in consumer world because of that.
And also the reason is because there are many decent solutions already there to solve that problem anyway. We saw this as a big gap, and that's why we had to do it, because we don't see anything that we can utilize. See, ultimately we are just trying to solve an enterprise problem with or without AI, because we saw that there is nothing like that existing, so we had to build it.
And Pradeep talked about something which is a illusion that AI gives. So I'll talk about something why he talked about that this was a big gap. Any team can pick up some of these commodity platform and they think that, well, I have done something in a week which is so good, it is doing me good results, like let's say assessment. If I want to create an assessment, I can create in 5 days, right? It will be good. It can do many things, and I'll have an illusion that, well, this is really the solution I want to take field. and then you hit one problem and you're trying to patch it and you spend months on that. This is a common phenomena in complex enterprise problems, as Pradeep is talking about. When you're looking at migration, again, I can do 80% good migration with any tool, but is 80% good enough? The remaining 20% is where people struggle, and we have seen it firsthand. So there was nothing which was solving this problem. And when we were deciding our journey, this was the biggest thing we learned, that commodity platform can do many good things, but for you to cover last mile, you need something which is purpose built.
It sounds like that, that your team has actually figured out the right way for harvesting the context, and not only about the code, but across the organization, across the enterprise. So, can you tell us more about what is that you are approaching or doing differently here?
Yeah. So first of all, what is context? So anything that you are going to give to AI in your request is the context, right? So the code that you are working on, if you are in ID, is the context. You will choose a specific code pieces and you will send it in your request. But then what about the code that is not in the current branch? Maybe that also has some knowledge which is no longer there in the ID currently, right? What about the Jira tickets which is not even connected, and so on, right? So unless you build that historical and wider view, you cannot make a good decision, and the AI will not give you a good output. So one thing is, of course, that you have to bring in all the right data together, and then it is not enough that you just get the right data together, because if your data is too large, now how will you select which data to send? And that's where people use RAG. But then in any system, when you use RAG, you have to, if you have, let's say 100 chunks which looks relevant, and finally you have to send 10, 15, 20, and then re-rank or whatever. But we have seen time and again, and that's not enough. And in fact, from the very beginning, at least from the coding side, we have deliberately not used RAG. We supported it. And we have seen that now industry has acknowledged that, and they have also moved away from that, because in an enterprise setting, your aim is not to get a quick answer. Your aim is to get the right answer. It is okay if it takes time, it takes a little bit more budget, etc. But we need to do targeted searches. We need to combine lots of relevant data together and get to the root of it, because that's what you were doing before AI, right? You want to solve a problem. It's not that you are trying to do quickly and not actually half solve it. So I think that's where we feel that context is very important, and we have multiple ways. For example, we feed in the context to model itself. We feed the context into various deterministic toolkits, and they all come together. And like I mentioned, for us, the context is a very, very large view of the data, not just the view that you may usually see directly.
And it's a fascinating world. RAG was the biggest talking point a few years ago. Industry has written it off completely. You see how industry says that, well, it is mostly end of life, where on one side models have started supporting a larger context, and on the other side there are new techniques that gives you much better results as compared to RAG. So two crucial things: one, you connect everything. You can't rely on one data source to get a holistic picture, and then you use that knowledge in a way that they are all connected and linked together. That is how the systems are going to sort of use the knowledge and deliver better results from there. And we have seen how some of the modern systems, the Claude, Cursor, they're all supporting MDs. What are these MDs basically? This is one way of feeding you the required context. You summarize everything into a one concise thing, and you can have different types of that. You make your prompt bigger. There are new techniques around it. But then for us, it was about first get everything together, make right relationships, use connected knowledge, and then feed it into your AI system for getting the desired result, whether you are writing code, you are doing planning, you are doing estimation, you are doing assessment, or even you are doing a simple things like just help me create a documentation for a product.
We talked about Cognition Lab earlier, which is very interesting, because if you look at the industry, most of the people are focusing on going towards one large model and trying to solve the problem, and sounds like that you are going in the opposite direction, focusing on small models and purpose built or task based or theme based approach. How do you look at this, where when the world is betting on scale, you are betting on precision? So talk more about what it is, what is your thinking behind it, and also how it impacts the cost and quality when it hits the production.
Yeah, so see, we strongly believe in purpose-built task models, whether it is for a specific task or for a specific domain knowledge. And it fits very nicely into our brain theory that we have, that while designing the brain itself, you can actually design with those purpose-built models in mind. So it can decompose the task accordingly. To talk about the cognition lab itself, so if you see what do you need to create these task models, so let me just talk a few points around that. So first of all, when you are fine-tuning these models, so first of all you need to create a data. So you need some proper scientific method to create those data points. So you need a data pipeline which is creating the data on an ongoing basis. Data could be your code, PRs, commit, Jira. It can flow from various directions, right? The second point is, once you have the proper data, whether it is code or domain data, etc., then you need to fine tune. And again, there are various techniques to fine tune, and not every technique, it's not one size fits all. So whether it is, you are creating those virtual layers using, say, PAFT and LoRa, etc., or you are doing full fine tuning and targeting very specific layers, feed forward layer or attention layers, or maybe you may be doing reinforcement learning, or you may be doing continued pre-training or distillation. There are so many different ways, and again, not one size fits all approach, right? When you use any of these techniques, again, there is a hyperparameter tuning that happens, because there are hundreds of parameters across all of these techniques. So there are lots of experimentation that happens, lots of validation that happens. Eventually you will get to know which task model is actually better for a specific task. And then finally the third pillar, which is about the model is ready. Now how do you do inferencing on top of it? Which is itself is a very, very big science, because if you are in a private on-prem world, which is largely the world in many enterprises, right? Because whether it's for cost or it is for security. Now, the problem is that if you have very limited hardware, how do you best utilize it? So whether it is KV cache, how do you compress? There are multiple techniques. There's lots of science there. And there are so many other ways you can enhance your inferencing experience. For example, you can do request batching to pack multiple requests into multiple messages into one request. So you have to do all of these things right. So we have created purpose-built pipelines to the extent that you just using one API, you can create a task model. You just send a request. At the end of it, you have a data, you have a model ready, which is already deployed, and maybe it is even exposed in an MCP server. So, and it did everything in between what I just mentioned. It curated the data, it selected the right fine-tuning methods, and or many other methods, did hyperparameter tuning, it compared lots of results, and then it eventually deployed it. And one thing that I missed to talk about in terms of inferencing, there are so many other techniques that you have to bake in. For example, even the decode and prefill phase of inferencing, you can actually have different chipset, because, for example, decode is a phase where KV cache is being built. It's a parallel work. It is primarily compute heavy versus the prefill phase I was talking about. The decode phase, on the other hand, is memory heavy. So you can actually have industries actually using different chips for this. So there are lots of things that have to come together to do each of these phases properly, and our cognition lab is heavily focused into all of these areas.
So just to simplify, What are we talking about? There are environments where you can't send your data out. But then if you use one large model in that environment, which is not trained on your data, you need to create lots of layer around it. If you want something which is just solving one problem, you can create a small model just to do that one task. Everything needed to create a pipeline to get you that model up and running is Cognition Lab all about. There are things which are coming in model. There are things that needs to be around orchestration infrastructure, and there are things which are around how do you use all that knowledge, how do you provide an inferencing infrastructure on top of it. That's where Cognition Lab is standing out. For us, it is about creating a very distributed ecosystem for every complex problems that we bring, which can contain your cost, which can give you the desired security, which can give you superior results as we talk about. And this is a lab which is inventing, creating techniques to do small improvement at every layer, so our result quality improves with that.
And we are specifically focused in the on-prem side using in the Mac world, where specifically in the Mac world, how do we solve this problem? So we have designed various techniques which are very, very tailored and customized for Mac studios as well.
Can we spend more time on the knowledge pipeline part? Can you take an example and explain that how the enterprise raw data points coming from whether code, documents or other system source of truth for information all coming into a system, and then the agentic solution, the AI solution is leveraging this data to create an outcome?
So we have a product which is part of our 4.0 release. We call it Helix. Helix is that infrastructure stack. Connect the systems, then you acquire data. The data will have to follow its required security guidelines. If I'm following ACL standards, what permissions I have, what can I use, what can you use, bring everything, get data, bring it into a central repository. You do the data transformation from there, use a transformed data, as Pradeep talked about, how it can be either used to create MCP infrastructure. You can use all of it to create a knowledge stack and then use it to create your purpose-built model. Helix does all of it together, giving you the necessary infrastructure, necessary nuts and bolts to stitch the whole data pipeline. Now, when we are talking about context earlier, we talked about it. You get code, you get a ticket, and you try and find relationship between all of the items. We look at lineage of certain information, an event which is someone reporting a problem, a system change happened, you have some of the trail in the logs, resulting into a code change, resulting into a deployment, and that yielded in closing a ticket. If I know the lineage of this event, the knowledge that I create is going to use all of it properly and build it at a place where it becomes meaningful to do one of these three layers, either MCP, context, or your fine-tuning material. And it has to be continuous, So Helix solves the problem that enterprise, where there are limited infrastructure, you want to bring this whole pipeline, you want to bring this continuous data sort of generation, data to be used for fine-tuning, for example, getting a model up and running. We ourselves were struggling with that. We realized that we need a stack to sort of govern everything. We need a stack to host everything. That is Helix story for us. It is a contained distributed system. You can bring it into an enterprise setup, connect your systems, connect all your resources, and it help you create pipeline, create necessary inferencing infrastructure. You can run models. It understands all the nuances, and we tried and exposing all of them over APIs, so you could do typical automation on top of it.
And one important thing is, like Nitish mentioned, it is difficult to get all the context together, fine-tune the model, etc. But it is even more difficult to maintain it. So something changes, then how do you change the ontology? Whatever you have already created the relationships graph, how do you now change the graph? And you are not creating those graphs and relationships from scratch. So you have to find innovative ways to plug that change back in a very optimized manner, including if you are fine tuning the models again. So we have a concept of delta fine tuning, which is also very unique. So at every layer we have to, when you are dealing with such a large context, which is ever changing, relationships are ever changing, then how do we solve and keep it up to date? Because if it's not up to date, then you will not get the desired results.
So interesting, Nitish. If you recall, I think 2 years back in the market, people were not comfortable having their code going out and the on-prem or the in private cloud. That story was very powerful and resonating well with the customer. But now we are seeing a trend that people are comfortable sending their code out. So how do you see this change? So are we seeing this? This is a local phenomenon, and maybe in the future when the smaller models become better and better, so again people will be more comfortable keeping everything in their ecosystem rather than sending anything out to a bigger model. So how do you see this journey going, and in future when some of these becomes better with a lot of science coming in, so on-prem will be a real story?
Even today, there are companies who are comfortable to use models on cloud, and there are some companies who are not comfortable doing it. But the if you see one of a shift that we see in the industry is people are going away from developer ID. We see CLIs, we see different type of interfaces coming out, which is helping companies solve not just a coding problem but everything around it. You can have a product manager creating a release plan. You can have like OpenClaw. I can do any home automation with that. I can solve my typical research project with that. So AI systems are going into a world where it is not confined by a code alone. When you are creating agentic system for code, it is still okay to send outside because it is mostly a metadata. Can you send your customer data outside? If I have a customer credit card transaction into my repository and I'm trying to do some sort of analysis on that, I still need something local, right? The on-premise story is relevant for anything which is sensitive in nature. The small model is relevant when you either want a superior result that your models are not giving you today, something which is contextual, or you want to contain your cost, which is a big factor. If today lots of these model companies are taking a hit on their P&L because they are passing on benefits to you, the model cost will increase if you do large context problem. They are all saying that. So you need to contain your cost. You will use small models. Many a time your models will be in-house because you want it closer to your system. Sometimes they are secure. So this world is here to stay. The hybrid, just like cloud, is a way to go, I guess. And that's just the way we see industry moving. Banking, financial, healthcare, at some stage they want to use agentic on almost everything. But no matter how comfortable they are with cloud-based models, they are still not so comfortable with sending sensitive customer healthcare record into a commodity platform. And they still need an agentic system to be in place. So we believe hybrid model will continue to evolve. Big models will improve every day, but the need for having purpose-built model, a need for having a local infrastructure will always be there.
And also, if you double click on the cost part a little bit, right? So what we have seen is that the token cost by frontier models, public models, is continuously going down. But you have to double click that. So what happens is, as you know, the input cost and output cost is like 4 times difference, right? Most of the new models which are better, they are reasoning models. They think. Think is output token. Whether you consume it or not, it is output token. So even though the per token cost may go down, but the request cost for quality output may actually would have gone up. And same thing is true for agentic system, because you are doing thinking so much, talking so much, agents are collaborating with each other. So overall, if you want a quality output, the cost is actually maybe going up, not down.
So, if you look at 4.0 as a whole, and a lot of these new capabilities which are added, and one of the context of adding these capabilities was to solve the business problem, like complex modernization, complex transition, and so on and so forth. So, do you see that with 4.0, we actually be able to solve some of these complex industry problems, or how? Where are we in that journey with 4.0?
Yeah, I mean, the traditional problems, modernization, migration, security, vulnerability, upgrades, you could do all that. We improved the result quality with 4.0, but 4.0 was a step towards bringing larger ecosystem in play. Agentic system that is distributed, connected to various resources. I believe for us, 4.0 is opening a new dimension altogether. Endpoint management, for example, is going to be seen in a different way altogether as agents are going to sort of take it over. One of the thing I want to talk about as we were designing 4.0, we realized that one of our product which is solving the endpoint management space, how we can use our 4.0 infrastructure to elevate the way you manage your endpoints. A few years ago, Pradeep was part of a team building C and Fix, for example, if you recall that time, Pradeep. C and Fix was basically you have multiple systems, you get all their events together, you detect a problem, and you can go and fix a problem. With this infrastructure, we believe that now you have agents. Agents can do lots of this analysis for you, but then you are still able to deliver similar good quality automation to this world as well, which was not what we designed it for. So the platform can go in multiple space. The platform can solve different types of problem, not just a coding assignment. The ability for you to use a brain is applicable even more in a typical agentic system. Today, agents hallucinate. It's a fact. People can say whatever they want to say, but can I have an agent? You talked about Kiro, right? So can you have autonomous agent takes control of sensitive system? No, you can't do that. You need the concept of brain in almost any agentic system, and it is not limited to coding, it is not limited to even a business process. It goes beyond that, like endpoint management, security. It can go in so many different areas and can give you something that was not possible before. This is why we believe a science of a very smart orchestration and ability for you to visualize everything, go back and forth, share the concept, bring your agentic system to most reliable state, and then use it to solve any problem. You can go in many different domain and do that.
And why we are confident that it will do a better job is because we ourselves are saying that it's not a single push button work anyway, because that is not going to work in enterprise setting, right? So what we are doing, what we have invested, if you take example of migration. So if you are doing a migration, we are going to define a very, very detailed workflow at the very beginning, and everybody is collaborating together. And while that happens, we are defining in a very, very deterministic manner various validation gates at various levels. So we are reducing the problem that AI might create, right? Because ultimately, like coming back to the same point, at 80% quality, is it enough? So you are using AI in enterprise setting because you want to be better, you want to do it quicker maybe, but not based on the quality. Not if it reduces the quality, right? That is non-negotiable.
So this is my final question. See, normally our videos are watched by different people in the industry. So for a CTO who has already invested in an AI platform, already wired things from MCPs and agents together, an architect who has tried the platform for solving a modernization problem and not was successful, or an engineering leader who was trying to capture the hype which was created by AI and the team was not successful. So what is the one takeaway you want to have for these people from your discussion?
So I think, like I mentioned in the beginning, that I strongly believe that neither a completely autonomous system where you push a button, give it many hours, give it lots of models, big models, is going to solve the problem. And similarly, on the other extreme, you have a developer, one single person who is maybe, in the ID, he has access to lots of repos, and then together he's trying to solve a problem using AI. I don't think we can succeed in using this kind of approach. So that's why, in 4.0, we have a completely different philosophy. The way Word was before AI, I think the Word will be very similar in this era with AI. So we have to use AI to its advantage, and we have to have proper guardrails everywhere. The systems should not be disconnected. They know about each other. They know their guardrails. They are working together in a collaborative approach. So we strongly believe that this is the way to go.
One thing that I want my viewers to understand, there is the complexity for in an enterprise setup is deeper. You don't underestimate that. We get very excited when I use some of the modern system and you get immediate quick result, and you're mostly certain that, well, I can solve many things with that. Don't underestimate complexity. When you look at your typical setup, you would realize that if there are distributed systems that are working together, then you need something more complex to be in place. You need a 4.0 orchestration system that can solve it for you. But then if you are working in a setup where you're solving simple problems, a developer alone can do fancy stuff, then in that world, you don't need something as detailed, as distributed as 4.0. And the productivity is not limited to an engineer. You have to solve everything. You have to bring context properly. You have to keep design first strategy in place. You will need proper review systems. Pradeep talked about a very important thing, that you can't have an autonomous agent or set of autonomous agent doing everything. We would like that world to come sooner. I think at some stage you would see intelligent, smart and accurate agents coming up. Till you don't have it in place, see it like a medical system that, while 80-90% efficacy sounds very good, but you can't trust it. A doctor will not go for a surgery if he thinks that the success rate is 80% in that, because that 20% is scary, right? Look at complexity and take design decisions. 4.0 is going to be live pretty soon. I think it is, for us, this is a way we were solving big problems. We are in a setup where you deal with a complex migration, for example, and you need almost a ready system to come out, not 80 or 90%. 4.0 is designed to do that. 4.0 is designed to bring the concept of brain, which is unprecedented. And because it is unprecedented, the approach we have taken with a visual way of you interacting with the system is our way of giving that interface. Tomorrow this interface may change. We will evolve. 4.0 is like a rebirth of our platform, where we believe that in a distributed setup we are setting the tone. As we get feedback, the interfaces may change. But just on a closing note, give it a try, understand why we are doing it, see how we have solved it, and then try and relate to your existing systems. For the CTOs who have invested in something, they can try a complex thing with their system. They can try the same with 4.0, and they'll see the difference there. They'll understand why we talked about a Steve Jobs story here, because if your story is not good, no animation can make your story look better. You need to have a solid architecture in place for your system to behave properly as you go along.
Thank you. On that note, we'll end this discussion. So one thing is very clear, that this space is evolving very fast and looks like that everything is possible. I think important thing is to have a longer term vision and clarity about the problem we are trying to solve and stay in that lane. So thanks for all of you for joining this discussion, and thanks to you, Nitish and Pradeep, for sharing your thoughts.
Thank you.
Thank you.
Thank you.